All right, in this review problem, we look at problem 4.16. We have 50 numbers between 1 and 50, and we pick 6 different numbers in a lottery game, where the order does not matter. Find the total number of ways to play the game if we pick 6 numbers out of the 50. Well, if we pick 6 numbers out of 50, there's 50. Choose 6 ways of doing that. There's 50 objects. We pick 6. So the answer is 50. Choose 6. And there's a whole bunch of ways of doing this. 15,890,700. So when playing the lottery, there are 15,890,700 possibilities if there are 50 numbers to pick from and you pick 6. Number 2, find the number of ways to play the game if 10 has to be one of the numbers that's chosen. So you can imagine the 50 numbers now have 2 groups. There's one group of 1, namely the 10, and then there's a group of 49. So we must pick the 1. So of the group that contains only the 10, we pick 1 number. And then of the remaining 49 numbers, we pick 5. So the answer will be 49, choose 5. 1 times 49, choose 5. So this is, I'm putting here for completeness. There's 110, and I pick 1 number from that group. There are 49 other numbers, and I pick 5 from that group. And so plugging in, this works out to be 1,906,884. So there are 15 million, approximately 16 million possible numbers between ways of picking numbers, of which about 2 million of them or so contain the number 10. Number 3. Find the number of ways of playing the game if exactly 2 of the numbers chosen are multiples of 3. Now, how many multiples of 3 are there? Well, there's 50 numbers possible. 50 divided by 3. So if we just do that on the calculator real quick, 50 divided by 3 is 16. So there are going to be 16 multiples of 3 that are between 1 and 50, namely 3, 6, 9, 12, all the way up to 48. So of the 16 multiples of 3, we pick 2 of them. Now, if there's 16 numbers that are multiples of 3, so 50 minus 16 is 34. There are 34 numbers that are not multiples of 3, and we need to pick 4 of those to complete the lottery hand. So 16, choose 2, times 34, choose 4. So this works out to be 120 times 46,376, or 5,565,120. And so that would be the total number of ways of playing the game if exactly 2 of the numbers that are chosen are multiples of 3. Find the number of ways of playing the game if at least one of the numbers is a multiple of 3. Okay, well, up here we figured out that there's 50 choose 6 ways of playing the game. Now, the opposite of at least one of the numbers being a multiple of 3 is that none of the numbers are multiples of 3. So I'm going to take the total number of ways and I'll subtract off the ways where none of the numbers are multiples of 3. There are 34 numbers, we just got done saying, that are not multiples of 3, and I will pick 6 numbers from those 34. So here's the total number of ways of playing the game. Here are the total number of ways of playing the game where none of the numbers are multiples of 3. If I subtract, that'll be the total number of ways of playing the game where at least one of the numbers is a multiple of 3. And so this works out to be 15,890,700 minus 1,344,904. And so subtracting, we get 14,545,796. So that would be the total number of ways of playing the game where at least one of the numbers picked is a multiple of 3. Okay, 5. This is the most interesting one. Find the total number of ways of playing the game if the difference between the largest number chosen and the smallest number chosen is 10. The largest number and the smallest number, the difference is exactly 10. Okay, so for this one, let me write out 6 blanks to represent my numbers. So that'll be my smallest number, here's some others, and that'll be my largest number. Now notice that this number here, say if this number was 8, then this number is 18. If that number is 20, then that number is 30. If that number is 40, that number is 50. Now, what are the possibilities for the smallest number? Well, the smallest number, there are 40 possibilities for the smallest number. The smallest number can be anything between 1 and 40. Because when I add 10, I have to get something that's less than or equal to 50. So I could have 1 could be this number, 2 could be this number, and so on. And then once this number is chosen, this number is specified. More on that in a second. Okay, now for the sake of argument, say that this is a 20 and that's a 30. Then the numbers in between are going to go from 21 to 29. So there's 9 numbers in between. Of those 9 numbers that go in between, I have to pick 4 of them. So 9 choose 4 would be the number of ways of picking the middle 4 numbers. So there are 40 possibilities for the first number. Then there are 9 choose 4 ways of picking 4 numbers from the next 9 numbers. Then once the smallest number is picked, there's only one possibility for the largest number. So in conclusion, the answer is going to be 40 times 9 choose 4. There are 40 possibilities for the first number. There are 9 choose 4 ways of picking the middle 4 numbers. And then if the difference between these two is 10, then the largest number is guaranteed. There's only one way of picking that number. So the answer is going to be 40 times 126. And so there's only 5,040 ways of doing this. So there's something like 16 million ways of playing the game, but only roughly 5,000 of them have this property that the largest number and the smallest number differ by 10.